Hello and welcome to the second lesson in Unit 0 in our Grade 10 academic math class. This is evaluating expressions. So we are going to look in this lesson at how to evaluate, which means sort of figuring out a string of numbers and operations and getting them down evaluated to a single final answer. The order in which we perform the operations in any expression is guided by this acronym that should be quite familiar to you called BEDMAS. So what I'd like you to do at this point is just pause this video and copy down this little reminder of what BEDMAS is into your notes. I'll talk about it quickly and then we'll start working through some of the examples. So hit that pause button now and come on back when you're finished. Okay, you're back. BEDMAS, of course, stands for all of the correct order of the operations you would perform in an expression. And it begins with a B, which stands for brackets. You want to complete anything inside any brackets first. The E stands for exponents. So after you have completed the brackets, you want to move on to working through the exponents, which we covered in lesson number 1. Then you want to perform division and multiplication as they show up left to right in the expression. So it's not necessarily first division and then multiplication. It's whichever of the two of them show up first. That is followed by addition and subtraction as they show up from left to right. So same thing, you might have subtraction before addition. That's not important. It's just important to do all division and multiplication that shows up before you do addition and subtraction. Okay, let's have a look at these examples. I've got the first one actually completed here. So we have 20 minus negative 12 divided by negative 3 all over negative 4 plus 12 in brackets divided by negative 2. So as I said in the last lesson, anytime you have a large, I guess it's a fraction basically, where you have this large numerator with operations to perform and a large denominator with operations to perform, there's an imaginary set of brackets around them. So we need to finish that numerator and finish that denominator as far as we can before we do the division. So for us, treating those like brackets, we'll have a look in the numerator. We don't have any other brackets in the numerator. We have no exponents, but we do have division. So what you have is negative 12 divided by negative 3, and that's where you get this, let me grab a highlighter here, that's where you get this positive 4 from. So negative 12 divided by negative 3 gives you negative 4. So 20 minus 4 is our worked through numerator, not quite finished yet. In the denominator, we actually have a set of brackets, negative 4 plus 12, and that's going to give us positive 8, and that's what's sitting right here. So in our numerator, we have 20 minus 4, that gives us 16. In our denominator, we have 8 divided by negative 2, and that gives us negative 4. So that's what we have to finish our numerator and our denominator. Now those imaginary brackets are essentially finished. Now we can move on to the division. And our answer, 16 divided by negative 4, gives us negative 4. And that's evaluated. So let's have a look at our second example. Example B is 1 1/4 squared times negative 4 over 5 divided by negative 3 over 4. So for us, we would want to look for brackets first, and some people would say, yeah, there's a bracket there, it's 1 1/4. This is not something that's necessarily required, but I think it's recommended to turn mixed numbers into improper fractions. And for those who don't recall how to do it, let me just do like a little shout out here. So the way that you do this is if you have 1 1/4, you are going to multiply the denominator by the whole number, so 4 times 1. And then you are going to add that to the numerator, which is another 1. That's going to give us 4 times 1 is 4 plus 1 is 5. So that is the numerator when you're making that conversion. Numerator. There we go. So in working through 1 1/4 squared, that's actually going to be 5 over 4 squared, and all the rest is the same. So next we want to deal with exponents, and as we recall, we're going to apply that to both the numerator and the denominator. So that's going to give us 5 squared, which is 25, over 4 squared, which is 16, and then the rest remains the same. So now we have dealt with the exponents. Now we're going to move to multiplication and division as they show up left to right. So we happen to have multiplication right here at the beginning. What I'm going to recommend here, actually what I'm going to insist here, is that you do as much reducing as you can for this little piece we're going to work on here, as much reducing as you can before you start the multiplication. This is, it's beneficial because what's going to happen is you're going to end up with smaller numbers, and in an effort to be less reliant on our calculators, we're going to be able to do these calculations in our actual brains. So when we're talking about reducing, essentially what we're doing is we're dividing both the numerator and the denominator by the same value. So if I was going to start, say, let me change up my color scheme. If I was going to start right here, what I notice is I've got a 5 and I've got a 25. So what I'm going to do is essentially divide that by 5, which is going to give me 1, and I'm going to divide that by 5, and that's going to give me 5 also. Fortunately, in this case, I can actually do the same thing with the other two numbers. So I have here a -4 and I have a 16. So if I divide 16 by 4, I'm going to be left with 4. And if I divide -4 by 4, I'm going to be left with -1. So I've done some reducing here. Now I'm actually going to do the multiplication. And as I said in the last lesson, it's numerator times numerator, denominator times denominator. So our numerator is 5 times -1, which is -5. And our denominator is 4 times 1, which is 4. And now we've got divided by -3 over 4. So what we have in this case now is a fraction divided by a fraction. What we're going to do to make that work for us is dividing fractions is the same as multiplying by the inverse of the second fraction, and the acronym that we use for that is KCI, where we're going to keep our first fraction, which is -5/4, and we are going to change division to multiplication, and we are going to invert the second fraction. Now from here, as before, we're left with multiplication, so let's do a little bit of reducing first. So here, I recognize that I have two values that I can reduce, that they have a multiple common to them. So I'm going to divide this by 4, and 4 divides into itself once, and I'm going to divide this by 4, and that goes in. 4 divided by 4 gives you 1. You'll notice that I'm doing an equal amount in both the numerator and the denominator. That keeps these fractions equivalent. And now multiplying the numerator times the numerator, I'm left with -5 times 1, which is -5, and 1 times -3, which is -3. Last thing we want to do here is if we have both a negative number in the numerator and denominator, essentially we want to recognize that a negative number divided by a negative number is going to result in a positive overall quotient. So I'm just going to write that as 5/3. Some people will ask, you don't have to change this into a mixed number. I prefer you to keep it as an improper fraction. And there you go. That one is now worked through. Hopefully that makes sense to you. Let's do one more example here. So this example here, we have 3 over 5 minus -1 over 10 minus 1 over 4 minus 1 and 2/3. So again, we've got sort of a steps that need to be taken in our numerator and our denominator. That means these invisible brackets sort of show up. So in order to work through the first, the numerator, what I see is that there's only one operation, and that is going to be subtraction. So I'm going to, when you're subtracting fractions, we are going to come up with a common denominator first. I have 5 and I have 10 as my denominators. If I multiply both the numerator and the denominator of my first fraction by 2, that will get me where I need to go. So I will rewrite this now as 3 times 2 is 6, and 5 times 2 is 10, minus, now we are subtracting -1. So if we're subtracting a negative, that's going to be a positive. Again, this is simplifying signs. We're going to add that to 1 over 10. Let's work the denominator now. Now in the denominator, same thing. There's just one operation that has to happen here. We have -1/4 minus 1 and 2/3. Now again, dealing with 1 and 2/3, a mixed number, is not great. So what I'm going to do in this second step is I am going to convert this to a mixed number, an improper fraction. So if I have 1 and 2/3, what I'm going to do is do 3 times 1, which is 3, and then I'm going to add it to my numerator, which is going to be 5. So I have 5 here. I'm going to keep my original denominator, and there we go. Now, in order to combine the fractions in the denominator, I need to come up with a common denominator. And what we notice is that we have 4 and 3. There is nothing common in them already, so I'm going to multiply one by the other. So I'm going to multiply the numerator and the denominator of this by 3, and the numerator and denominator of this by 4. And this is not a bad strategy at all when you're trying to find a common denominator, is you can just take the two denominators you're trying to find a common factor for, or a common denominator for, and just multiply them together. So our common denominator in this case would be 12. It happens to be the lowest one as well. That won't always be the case, but it will always work. So let's move on to our next step, and in doing so I'm going to simplify my numerator. So my new numerator is 6/10 plus 1/10 is going to give me 7/10. And I'm going to rewrite this having done the multiplication. So we have -3/12 minus 20/12. In our next step, I am going to just rewrite the numerator because I need a little more work on the denominator. And here we have -3/12 minus 20/12. So that's going to be -23/12, which ain't pretty, but it is what it is. So here we have a fraction in the numerator, a fraction in the denominator. Essentially now those brackets in our numerator and denominator are finished, so we can move on and actually divide these. Now, as I said before, if you've got 7/10 being divided by -23/12, we can once again apply the KCI to make this work for us, where we are going to keep the first fraction, which is 7/10, change division to multiplication, and invert the second fraction. Now we're at a place where we can do some reducing before we multiply. So in order to do that, I recognize that 7 is a prime number, so is 23, so we can't do anything there, but I recognize that 10 and 12 can both be divided by 2. So dividing 10 by 2 gives me 5, dividing 12 by 2 gives me 6, and now I can do the next step, multiplying the numerator by the numerator. 7 6s are 42, and 5 times -23 is, let's see, that's 5, 1, -115. And again, in this last step here, I just want to get the negative out of the denominator, so I'm going to just relegate that to the front of the whole fraction, and that is our final evaluated answer. So there's the first 3 examples. This is just evaluating using BEDMAS. When you come back for part 2, we're going to be doing some substitution and evaluating for variables. So we'll see you in part 2.